Alright, so in today's lesson, we're going to learn the topic electromagnetic induction. We're going to learn the topic electromagnetic induction. Alright, so we need to define what electromagnetic induction is. So by definition, electromagnetic induction is a process by which an electric current or voltage is produced in a conductor when the magnetic field around it changes. So this is simply the process by which an electric current or voltage is produced in a conductor when the magnetic field around it changes. Alright, now let's look at Faraday's law. Faraday's law. So Faraday's laws of electromagnetic induction simply states that the strength of the induced EMF is direct proportional to the rate of change of the magnetic flux. So Faraday's law of electromagnetic induction simply states that the strength of the induced EMF is direct proportional to the rate of change of the magnetic flux. So that is what we call the electromagnetic induction. Alright, so how does this happen? So for example, we're going to get a U magnet, a copper wire connected at the curve with a galvanometer. Then we're going to move that copper wire up and down in the U-bend magnet there, and you'll notice that the galvanometer won't deflect. But when you move the copper wire perpendicular to the direction of the magnetic wave of a U-bend magnet, you'll notice that the galvanometer will deflect. So when this happens, this simply means that current or voltage has been rejected. So that's how electromagnetic induction occur. Only by cutting the magnetic field of a magnet by 90 degrees. That's why I use perpendicular there. By 90 degrees, that's when only current is produced. If you don't cut the magnetic field at 90 degrees angle, you won't produce any current or any voltage or any voltage. That's how this principle works. Alright, now let's look at when you're dealing with a solenoid. When you're dealing with a solenoid. So when you're dealing with a solenoid, what happens is that when you start moving the bar magnet towards the solenoid, that bar magnet or the solenoid will create a magnetic field that will repel the magnet. But when you move the solenoid inside to the middle, no electromagnetic induction will occur. Nothing will happen. As you begin to move, continue pushing the magnetic bar through the solenoid and coming on to the other end there, you'll notice that the solenoid will create a magnetic field that will attract the same bar magnet. Okay, so now we know how to identify the poles on the solenoid. Just follow what happens. If you are moving the bar magnet into the solenoid and it is repelling you, just know that it's a north pole. Since you are entering the solenoid using the north pole part of the magnet, so automatically that makes it the north pole as well. Since when you are taking out the bar magnet on the other end of the solenoid, it's attracting it, so automatically that means that on the other side there it becomes the north pole again to attract the south pole again. I hope it's clear there. Alright, so in conclusion, you can simply say if a magnet moves towards a solenoid, the solenoid makes a magnetic field tending to repel it. If a magnet moves away from the solenoid makes a magnetic field tending to attract it. Then current flows according to their magnetic field. This is called Lenz's law. So how do you increase the EMF induced? How do you increase the EMF induced, which is the current? So number one, you move the magnet at a higher speed. Then number two, you use a stronger magnet. Then number three, you increase the number of turns in the coil. Alright, so once you are done with that, we need to look at what we call the AC generator. An AC generator. So an AC generator generates alternating current by electromagnetic induction. So alternating current is simply the current which changes its direction a number of times per second. So the structure is simple. AC generator looks like that. So yeah, what you call the strip links, the carbon brushes, the core, and of course our magnet there, even our carbon carbon brushes. All right, now let's identify the function of each this part. All right, so what is the function of the core? So the function of the core is simply to produce electricity by electromagnetic induction. Then the other part is permanent magnet. What is the function of the permanent magnet? So the function of the permanent magnet is simply to produce the magnetic field. What is the function of the carbon brushes? So the function of the carbon brushes is simply to keep the contact. The carbon brushes keep the contact with the rings continuously. Then the core is electrically connected to the outer circuit. There's the function of the stripling. So the siblings are fixed to the core. So all of them are drivers rotating in a body by the outside power source, like an engine or a turbine. If the siblings are replaced with the split ring commutators, the generator becomes a direct current generator. Alright, hello everyone. Thank you for watching. My name is Robert Mtare, and I hope you have enjoyed the lesson. If you are watching this, which means you have reached up to the end of the video. I'm so proud of you. Just don't know how happy I am because of you. Because there are very few who do that and which actually reach at the end of this video. So a quick one before you go, just a quick one. We're always running our online tuitions, and what we do in our online tuition is that we focus on topics that only comes in the exam, in the exam. That's what we teach on the TV. It means that if the topic is in the syllabus yet it doesn't come in the exam, here at Mtare TV we don't teach that. Why? Because we know at Mtare TV online tuitions, time is very cardinal. Time is very cardinal, so we don't waste time on Mtare TV. We only teach what comes in the exam, which is in the syllabus. Thank you for watching. If you haven't subscribed, please subscribe. If you haven't liked, please like. If you haven't comment, please comment. If you haven't joined our online tuitions, please join our online tuitions. This is Robert Mtare, your tutor. Thanks for watching. Bye bye.